Hi, welcome everyone to the video lecture on VLSI design and testing. So in today's video, I'll be discussing on the components of VLSI technology. So what are the key components that are used in manufacturing of a VLSI design? So these components can include transistors, logic gates, memory cells, interconnects, and power distribution network. So let's see one by one how they are used in order to manufacture the VLSI chips. So here the transistors are considered as the fundamental building blocks of any VLSI design. They are the semiconductor devices which can amplify or switch the electronic signals that are used to implement logic functions and memory elements. So transistors are fabricated using silicon-based technologies, which includes the complementary metal oxide semiconductor, that is the CMOS technology, or the bipolar junction transistor technologies. Next, logic gates. So logic gates can be considered as the basic building blocks of any digital circuits in order to perform the logical operations such as AND, OR, NOT on the input signals. So these logic gates are implemented using transistors and they can be combined in order to create the more complex logic functions. So the examples of this logic gates include NAND gates, NOR gate and XOR gates. And when it comes to the complex logic functions in VLSI, they can be also classified as the AND OR invert and OR AND invert, that is the AOI circuits and OAI circuits are also considered as the complex logic circuits which are built with the help of the simple logic circuits like AND, OR and NOT. And also we require a memory cells in order to store and retrieve data that are required for the electronic devices. So these are implemented using flip-flops and also with the help of static random access memory cells. Next, commonly used technologies which are for the VLSI design. So as discussed in the first video, what are the different types of technologies like bipolar, CMOS, SOI, BiCMOS. So here we'll discuss basically on the complementary metal oxide semiconductor. So complementary metal oxide semiconductor, bipolar junction transistor and field effect transistors are the different technologies. But the complementary metal oxide semiconductor is the widely used technology. So what is a complementary metal oxide semiconductor? It uses both P-type and N-type transistors, which are called as the MOSFETs, in order to implement logic functions and memory elements. So the advantages of this is low power dissipation, high noise immunity, and compatibility with digital and analog circuits. Bipolar junction transistor technology is another technology which is used in VLSI design. So the advantages are high speed operation, high drive current capability, and compatibility with analog circuits. So BJTs are used in applications which require high frequency operation such as radio frequency amplifiers and high speed digital circuits. Next is the field effect technology, transistor technology, which includes both metal oxide semiconductor field effect transistors and junction field effect transistors. So MOSFETs are the technologies which are MOSFETs are the transistors which are used in CMOS technology. And JFETs are used in specialized applications where it is required, such as low noise amplifiers and high impedance circuits. Next, why are these memory cells required? So memory cells are required in order to store the data which will be in the form of zeros and ones when it comes to the digital circuits in order to implement the registers and memory arrays for the VLSI chips. And interconnects. So interconnects are used to connect various components and circuits on a VLSI chip. So this interconnects will be implemented using metal wires or vias and are used to route signals and power between different parts of the chip. And also it requires a power distribution network. So in order to distribute the power to the various components and circuits on a VLSI chip, which includes the power supply lines, decoupling capacitors and voltage regulators. So the power distribution network will ensure that each and every component and the circuit, it receives the required power and it will operate within the specified voltage limit. The advantages of using VLSI technology is reduced size of circuits, increased cost effectiveness for devices, improved performance in terms of operating speed of the circuits, requires less power, high device reliability, requires less space and promotes miniaturization. Applications includes consumer electronics, automotive electronics, telecommunications, and in order to implement the digital signal processing. So when it comes to the consumer electronics, it can be a design and manufacturing of smartphones, tablets, gaming consoles, and wearable devices. Automotive electronics, in order to implement the functions like engine control, brake control, and multimedia interfaces. Communication systems such as mobile phones, base stations, and network routers. And for digital signal processing, the modulation and demodulation functions which are required for the wireless communication. Thank you. Thank you for watching the video. In the next video, I will be discussing the basics of MOSFET. Thank you.